Hi, this is part 2 of our Rhinocam tutorial for working with an intro to foam project. So in the last tutorial we set up our layers in our file. We learned a little bit about working with Rhinocam at UMass, and we learned how to open up the machining operations and set up our machine job. So you've got your 3-axis machine in here, you've got your Techno ISO post, and you've got your box stock ready to go. So if we turn off the stock here in the model, we can see that it's working in Rhinocam. Okay, so we're going to get ready to start doing some operations. And under here in machining operations, we have a number of different options. The one that we're going to be working on primarily today is the 3-axis operations, which we have a 3-axis machine here at UMass. This is the primary thing that we're going to be working with. There's a whole bunch of different operations here. The ones that we're going to be working with on this project are primarily horizontal roughing, which eliminates a lot of material, and then a couple of finishing operations, the first of which might be horizontal re-roughing. That looks like contour lines on a drawing, or parallel finishing, which finishes in parallel lines. The way that we actually have this set up for you to make it really easy is that we have something called knowledge bases set up. So if you go in here, go under machining operations, and it says K bases. So you click on this, we'll be passing these around, and you're going to go to the intro to foam knowledge base. And what this really means is that we've already set up the operations for you with the tools that we own in the lab and all the settings for the tools. So you don't have to set up which tools you want. You can just start from here as a jumping off point. So to start with, we're going to start with the parallel finishing, and what you can do, these are just all different operation setups. You can drag and drop right in here. So we're going to get started with the first one, which is parallel finishing. So the thing about Rhinocam is that it's going to view what's turned on in the model, and it's going to set up toolpaths to work with what is on in the model. So for example, here I actually have 2 surfaces. If we render it here, you can see that I set up 2 surfaces just to show this. So you can see 1 and then 2. So we're going to start with surface number 1. Now if I turn off surface number 2, Rhinocam is not going to set up toolpaths along surface number 2. The other thing that I have turned on here is my regions layer. So I've got a couple of different things set up, but the primary one is I have a region that outlines the entire model, and that's what we're going to be working with. So we start here with horizontal roughing, and in this first window we're going to define the region that we want Rhinocam to consider and to set up toolpaths in. So we select drive containment regions right here. We're going to click on that outer outline, which is a curve that I've kept on its own layer, hit return, and so if you click on this you can see it goes green. So the second thing that we're going to do, this is already preset for you. For horizontal roughing we're going to use a 1/2 inch tool. So if we click on this, you can see how each tool is set up. This isn't something that you have to do, but you can see that here we have a 1/2 inch flat tool that we've defined as being used for roughing operations. It's a 3-flute tool. What you can see is when we set these up, you have all these different tools up here, types of tools, and then as you start to define, say, the holder, the shoulder, the shank, the tool length, it sets it up right here. So in fact, our tool that we're going to be using is 6 inch, so we're going to save the edit to that tool, right? And if you click in here, you can see that for our flat tool, we've already preset it to 6 inch. We've got, under the ball mill, we've also got a 6 inch that we've been working with for foam. So I'm going to say OK. And we've preset these with the feeds and speeds that need to be used. So when you go in there and you choose it, you just go in, feeds and speeds, you load from the tool, which have already been preset in our tool library. So the clearance plane is important. That's actually how much the tool lifts up over the part or the model or the stock before it comes down. And a nice thing to do is to set it to the stock plus a distance of, say, 1/2 inch, 3/4 of an inch. But for the purposes of this model, we can just keep it on automatic because we've already tested this project and we know that it works. For the cut parameters up here under the global parameters, we're doing a roughing pass. So this is how close you're actually getting to the model, to the part. And in terms of our roughing, we can leave a little bit extra here. We don't want to go so close to the part. We want to leave a little extra. So we've allowed some extra material there. We're going to use the pocketing stock offset option, and we're going to use the mix cut direction. The thing that you really need to be concerned about in the cut parameters box, the only thing you really need to play with is the step over. So this is how much of a diameter, percentage of the diameter, the tool moves over each time it's passing back and forth. And for this roughing pass, we can really go pretty big, like almost the entire tool diameter, 90%. If you're finding that it's taking off too much, you can come back here and set it lower, but this is really where your time is factored in. The lower you go, the more time it takes. On the cut level, we're also going to be jumping down the full tool diameter. So we're going to save that for now. We're going to generate it. And so what we can do now, oops, as you can see, those are the tool paths. So all the blue lines are where the tool is moving around the part, cutting away at material, and all the red lines is where it picks up and it moves across. So now we can go into there's two tabs here, the Program tab, which has your operations, and the Simulate tab, which shows you what's going to happen. So for this, what we're going to do is we're going to turn off the part, we're going to turn on the stock, and for right now we're going to turn off the tool path. A little bit of a, there we go. Yeah, it looked to me like that was a little small, so I thought it might have bumped up to 1/2 inch for some reason. I'm going to go back, make sure that we have selected the 1/2 inch tool, and then I'm going to regenerate this. There we go. Now we have a 1/2 inch tool. It's taking much bigger chunks of material out. It's going to move a lot faster. Okay, so the next thing that we're going to do is we're going to do some parallel finishing. So for this one, we're going to, oops, let's turn our model back on. So we're going to select the drive containment region. This time we're going to choose a flat 1/4 inch tool. Make sure that we're loaded from the tool. Our clearance plane can still be on automatic. And here we can set these to 2 if you want to. And in this case, the stock can go down to 0. If you're going to do any custom engraving or trying to get some tool paths going in a different direction, you could leave a little bit of stock there. In this case, I think I'm going to leave a tiny bit. And then here, a 25% tool diameter will give you not a super flat surface, you'll still see some graining, but it'll give you a pretty nice surface. And then the rest you don't really need to do anything about. So we're going to generate that tool path, and then we can simulate it. So you can turn on the toolpath visibility, but you really only see the toolpath then. It kind of clogs up the screen. So I'm going to turn that off just so I can watch the surface being generated. This is going to really take a little while. There we go. So in this case, you can see I left a little bit on, and so we're seeing some of the patterning from that horizontal roughing. So if I go in and I say to just take that down to 0, I think you're going to quickly see that that's going to disappear. Okay, so that's what it's going to look like there. We got rid of all those horizontal roughings. So one of the reasons why I created the model like this is I thought it would be fun to show what happens if we then go in and turn on the other surface, and then we set a ball end mill toolpath in there. So what you can see here is an example of the flat end mill when I set it to a 25% step over. So it's smooth, you really get to see the surface, but it's not absolutely smooth. If you wanted to get a very smooth surface, you might want to go down to 5%, but that's going to take you an awful long time. But the flat end mill really does produce this very fine, smooth surface. By contrast, the ball end mill is going to give you this kind of really interesting scalloping. So depending on what you're looking for, you might want to use both on your surface to really create some texture. And by contrast, instead of 25%, I think this one was set to 75 or 80% of a step over to really get some of that scalloping going. So for this one, you have this other operation here using a ball end mill. And so what I've done is I've actually set up these other regions, these mini regions that are crisscrossing, not the whole region that outlined the full model. And then we're going to use the ball end mill here. And so I think just for contrast's sake, we'll pump it up to, actually we'll pump it up to 90 so we can really see the tool paths. And I think what you can actually see here, you can see the tool paths are quite different. You can see that scalloping, but you can also see that right now it's moving in the same direction as the parallel finishing. So I think with the end mill, so I think what I'm going to do is I'm going to go in here and I'm going to decide that the angle of cuts is actually going to go at a 90-degree angle so that we can really see the contrast. And just to show you what's going on, let's actually let's regenerate. Let's actually select another region. So we'll add a region here. I'm going to add this other region that I set up, and actually one over here as well. So now we have 3 drive regions. So if you click on them, you can see that they're highlighted in green. I'm going to keep my tool, but I'm actually going to bring this up to 110 so that we can really see it. So you can see I actually have 2 surfaces, the one that are intersecting. So sometimes they're intersecting and sometimes there's really nothing to cut through. This is just an example, but if you wanted to work on sections of the same surface that you had already prepared, you could do that as well. And then to finish up, what we're going to do is we're just going to profile the outer edge to separate the piece, the part. From the foam that it's sitting in. So we'll use a flat 2.5 axis. We're good here. The thing to pay attention to here is really just the cut level. So we're not going to go all the way through the full 2 inches of material. We want to leave just a little bit, and what you're going to do then is cut the final out with a with a mat knife.